Okay, remember when we talk linear functions, linear, we're using y equals mx plus b. So this is something that you've been using for a while. We're just going to apply it today. Okay, there's our learning goals for the day. This is the first big thing you need to write, okay? And I'm going to add a little note up here at the top to find the slope between 2 points. Okay, we need to identify those points as this and this. So we have x1 and y1, and then x2 and y2. This should be familiar. One thing I want to highlight here before I go further is that I could, if I wanted to, for whatever reason, change this to this one to x2, y2, this one to x1, y1. That's fine. What I can't do is change this one to x2, leave this one as y1, change this one to x1, leave this one as y2. I can't mismatch them because now I've created two totally different points. These would be two totally different points on a graph, would not be the same line, totally changes the problem. Okay? Does that make sense with what we can do there? Okay, then from there, this is a really, really big piece of what we're doing today. Okay, the change in y over the change in x. You've heard it as rise over run. To find the rise, we subtract y2 minus y1. To find the run, we do x2 minus x1. Rise is up and down. Run is left to right. Notice I said left to right, not left or right. Okay, then if x2 minus x1 equals 0, we can't do it. It's undefined because we would end up with a vertical line. And we'll get into that more a little bit later. Okay, so here's our first example here. They're asking us to find the slope of a line that passes through these 2 points. The first thing that I do, still, as an adult, is I go x1, y1, x2, y2. I label them every time. This helps make sure that I don't get things mixed up. So now I have to do y2 minus y1, right? So I'm going to do 5. And is it just 5 minus 2? No. This is a really important takeaway here that sometimes can be easily messed up. It's 5 minus a negative 2. I think it's important to write that out. Over negative 1 minus 4. Now this goes back to middle school math. A positive number minus a negative number is actually addition. So I'm going to do 5 plus 2. 5 plus 2 is 7 over. Now I have a negative minus 4. So it's going to be negative 5. Now one thing I want to point out here is we have the negative on the bottom, right? Okay. That doesn't mean now that we're going to go left 5. Okay. This is really negative 7/5. Okay, and I always like to identify that as m. When I get done, I'm going to put equals m. That negative is going to be applied to the 7. I'm going to go down 7 because it's negative 7. And then for the 5, am I going to go left or right? Right. Okay, we always go to the right. So I'm going to go down 7 and then to the right 5. Down 7, right 5. Okay, now I want to change this problem a little bit, okay? Don't change it in your notes. I'm just going to change it here. Let's say that this was negative 5 minus 2. Then what would we have on the top? That'd be a negative 7, right? How would that affect my slope now? Because now I have a negative on the top and a negative on the bottom. Yes, because a negative divided by a negative is a positive. In middle school, at least at Papillion Middle School, we taught this using Monkey Man. We cross out the two negatives, negative, negative. We end up with a positive. Okay? So that's something that you need to remember is how those negatives impact your slope. This one should just be negative 7/5. All right, next thing is y equals mx plus b. We're going to label these parts, so leave some space around it in your notes. Okay, the y is my output, and it's going to be in my ordered pair. The x is my input, and is also going to be in my ordered pair. Because we have x, y. The m is my slope, which is rise over run. And the b is my y-intercept. So now we're going to use this and what we just learned with finding a slope to write something in slope-intercept form. Okay, so now I have 2 points again. So the first thing I'm going to do here, this is x1, y1, x2, y2. So what's the first thing I need to do here to be able to write this in slope-intercept form? I have to find my what? Slope. So I'm going to do 6 minus negative 2 over 3 minus a negative 3. Because I'm subtracting a negative, this turns into plus. So I end up with 8 over 6, which can be simplified into 4/3. And like I said earlier, I like to put equals m so that I don't forget where it's at. Don't want to lose it. Now I have to find the other part of my slope-intercept form. What's the other part that we have to have? I've got my m. What's the other part of my equation? I've got a y, I've got an x. They're right up here in my ordered pair, right? There's my y, there's my x. Or I can use this one. There's my y, there's my x. So I've got a y, I've got an x, I've got an m. What don't I have yet? Y equals mx plus what? B. I don't have a b. So we're going to go find our b now. And I'm going to use one of those two sets of coordinates. Do you guys want to use the green one or the pink one? Pink. I'd use the pink one because that doesn't have any negatives, right? Okay, so I'm going to say y, which is 6, equals 4/3, because that's my slope that I already found, x, so my x is 3, plus b. Are we all okay with where we got that 6 and 3? Okay, now this is just a little bit of a math review. This is 3 over 1. If we want to think about this as cross-reducing, the 3's would cross-reduce into 1. So then we have 4, right? Or you can think about it like this. Multiply your denominators. 4 times 3 is 12. And then divide by 3, which is 4. Either way, we get 4, right? So it's going to be 4 plus b equals 6. And now to solve for b, I subtract 4, right? So b equals 2. my next piece. Now I'm going to use those pieces to write my equation. Y equals, my slope was 4/3, so I just plug that in, x, and then it's going to be plus 2 because it's a positive 2. That's our final goal. You cannot get what's in green without doing what is in the red and the black, pink, and blue. You have to do that in order to find the green. Okay, now we're going to talk about graphing them. So what I want you to do first is in your notes, sketch a little coordinate plane, please. Okay, now we're going to plot this first one. I'm going to cover up the second one. Okay, we're going to plot this. For those of you that like steps, step 1, okay, is we're going to plot the y-intercept. What's our y-intercept? 1. So I'm going to go up 1. Okay, now step 2 is we plot next point or points using slope. So our slope is positive, right? You guys agree with that? So positive slope means that our airplane is going to be taking off. In some way, the line is going to be doing this. It's going to be going up. Okay? Those are all positive slopes. See what I'm doing there? Oh, got a little too far. Those are all positive slopes. Okay? The plane is taking off. Okay? Negative slopes are like this. The plane is crashing. Okay? Negative is bad, right? Plane crash, bad. Plane taking off, good. Okay? So we should have a plane taking off here. So we're going to go up 3. So I'm going to use my laser pointer here. 1, 2, 3, and then over 5. 1, 2, 3, 4, 5. So that right there is where my next point is going to go. Okay, for this one, because the spread is pretty far, I'm not going to do another point. I'm just going to draw my line through my 2 points and be done. Okay, now we're going to do our next one. Is this one in slope-intercept form? No. So we have to get it into slope-intercept form. So how am I going to get it into y equals mx plus b? I want to isolate the y. I'm going to have to add 5 to both sides. Y equals negative 2x plus 5. So right now, are we going to have an airplane taking off or an airplane crashing? Crashing. We're going to have a negative slope because that is a negative 2x, right? So step 1, I'm just going to use the same coordinate plane. I'm going to use blue. Plot my y-intercept. This one's 5. Okay, now do I just go down 2 like this? Down 2 like this? Is that how I do this? No. Lex, what do I do then? If I don't just go down 2, it says negative 2. It's negative 2 what? Over what? Negative 2 over 1. If it's a whole number, it's over 1, right? Negative 2 over 1. So I'm going to go down 2, 1, 2, over 1. Then I go down 2, 1, 2, over 1. Our plane is crashing, right? There we go. Any questions on those two? Carson?
How many points would you want us to plot when we're doing this?
I think it depends on the spread. Like that blue one was a little bit closer, so I did a third one, right? And it just helps make sure I draw my line straight enough. If the spread is far enough apart, like the red one, I think 2 is fine.
Okay, got it.
Yep. All right, next portion here. All right, I'm going to pare this down for you. So we're going to write horizontal line, y equals b, slope is 0. Vertical line, x equals a, slope is undefined. So remember, b is our y-intercept. So if the y just equals b, that means that every time we put something into the function, into the equation, we're going to get b, which is our y-intercept. So that's why we're going to get that horizontal line. For the bottom one, that's when our x's would be the same. So x2 minus x1 equals 0. That means that it just goes up. It's just a vertical line. Okay, so for this one, it's y equals 3. And I would sketch this in your notes just so you have it as a reference. Y equals 3, that's going to be simply a horizontal line through 3. Oops. Just like that. Okay, to put this into our whole form, this is y equals 0x plus 3. So if we wanted to think about, like, if we put in a 1 times 0 is 0 plus 3 is 3. 2 times 0 is 0 plus 3. And then it would look like this. Oops, that's supposed to be a 4. Our table of values would look like this. Every time we're getting 3, right? So that's where we get the horizontal line. All right, last question we're going to do here today. Okay, and this is one of those that looks intimidating. Like it is right now, it looks intimidating. There's big words in there. They talk about obtain a linear function that models average global temperature. All this is the same question we did right here. Okay? This one just uses 3, -3, -2, 3, and 6. This one's just using some different numbers. Okay? But do we have 2 points on a graph? We have 2 ordered pairs, right? So this one is x1, this one is y1, this one is x2, this one is y2. So because the problem is a little bit more like wordy and has more complicated numbers, do we change our strategy? No. We're going to do y2 minus y1. 57.64 minus 57.04 over 354 minus 317. What are we finding right now? We do this to find the slope. So on the top, we're going to get 0.6. On the bottom, 354 minus 317 is 37. We don't want to leave that like this because we have a decimal in our numerator, so we're just going to punch that in. 0.6 divided by 37 equals, it's like 0.016262 or something. Okay. Now this is where we have to go back to the question because the question gives us some guidance on this. Round m to 3 decimal places. So 3 decimal places would be right here. So if I'm going to round that, m is going to be equal to, do I give it a shove or not? No, because 2 is less than 5. So it's going to be 0.016. That's my slope. That's important. I need to come back to that. Now I need to solve for my b. So I'm going to use one of these 2 points. So I'm going to use the first one. So we're going to do 57.04. That's my y equals my m, 0.016 times my x, which is 317, equals, or no, plus b. Do we know how to solve that? Yeah, we know how to do that. So we're going to multiply first. For my multiplication, I get 5.072 plus b equals 57.04. Then we subtract. And I get 51.98968. Then we go back to our directions again. It says B to 1 decimal place. That would be the tens place, right? Well, in this case, if I round to the tens place, it's actually going to bump it up, right? Okay, so my final equation is going to be y equals my slope, which is 0.016x plus 52, because we rounded our b. Okay, this is your homework for today. It's actually all up there. All the pages are actually up there on Google Classroom.